So we're still in section 7.2, but now we're going to be looking at event-controlled loops. And the difference here is, unlike count control, you don't know how many times it'll repeat. Don't know a priori. So coming into it, you don't know how many repetitions. Repetitions, who cares how it's spelled, right? The idea in a count control, so for count controlled, you would know that it would be doing it 10 times or 5 times. However, you have some limit, right? But this is not count controlled. For an event controlled, we just don't know. We don't know how many times it'll repeat. And here is an example from your book of an event controlled loop. I'm going to start using just a flow chart, right? So you can imagine that you are coming in and you're making a decision, and based off of that decision, if it's true, you execute some body of code, and then come back to the decision. If it's false, then you go after that body of code and continue to execute some other things. Up until now, our condition has been based off of something like is some counter less than some limit. But what we could be doing is, for instance, we could read some number, let's see, x, right? And we could be checking here, is x greater than 0? And if it's true, we could have two steps. We could say print x, and then we could read x again. So if you imagine that this is your flowchart, then the way that it would work is you would have here some value x. And after this line, can you predict what x is going to be? You can't, because it depends on what some guy out in the environment types onto his or her keyboard. And you can't, as a programmer, possibly know this because it comes from outside in the environment. So let's imagine that he wrote a 7, right? So you come in here, you can say, is x greater than 0? Yes. So now we read x again, or actually we print out the x. So here we go. That's an output command. You print out the x and he sees 7. And then you read in a new number. So can you tell now, is x going to stay 7? No, because you have no idea what he's going to type. He might type in a 3. So after this line, the value of x would change from a 7 to a 3. You come back up here, is x greater than 0? Previously it was true, and it's still true, right? So you come back in here, you're going to print a 3 out to him, and you're going to read the next x, and you have no idea what he'll type. Maybe he types in a -1, in which case that condition becomes false, and you continue, right? The important point here is I did not know how many times I would traverse this loop until I actually ran the program, right? So you generally don't know a priori how many repetitions. Let's look at this in pseudocode. There is pseudocode that says it counts the positive numbers up to 10. So read 10 positive numbers. I just made up a name for some procedure. Okay, so here's my procedure. Read 10 positive numbers. What's it going to do? It's going to add, it's going to calculate their sum, and it's going to ignore the negative numbers. All right, so I can put a little comment here. I'll use 2 slashes to indicate that it's a comment. Ignore negative numbers. and print sum of next 10 positive numbers. Every line that begins with 2 slashes is a comment. So just like in assembly we had a semicolon to start off a comment, in our pseudocode we're going to use 2 slashes. 2 slashes is commonly used in languages like C, C++, and Java, so we'll use it here. In Python they use a hash symbol, so I could use a hash symbol as well since this course is based on Python. But your authors use 2 slashes for comments, and I'll stick to that as well. So in order to read in 10 positive numbers, we're going to keep doing a loop and adding them up just like before, but the difference is we don't know how many negatives the user is going to type in, so we can't predict how many times the loop needs to repeat. Let's see how that looks in code. I'm going to create a variable called sum to hold the sum of those 10 numbers, and I'm going to initialize it with a 0. And now I'm going to keep track of how many positive numbers I've read. So this is my counter, and I'm using leading lower camel case as the name. I'm going to set my counter to 0. And while, so here's my while loop. So I'm going to keep repeating this loop as long as the number of positive numbers I've read, which is kept in pos count, is less than the limit I want, which is 10. So this is going to generate, hopefully, a sequence that goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and that would be 10 numbers, right? So it won't actually generate the 10, but it'll generate a total of 10 numbers, starting with the 0. Okay. So while pos count is less than 10, I'm going to read in a new value. And the trick here is I only want to increment pos count if this value is greater than 0. So I don't know whether 0 is technically considered a positive number or not, but we're not going to consider it positive. So we haven't done this before, but hopefully you can recognize that these structures that we're using in our pseudocode are kind of recursive, and they can be nested. So here, this whole procedure that I'm writing is a block of code. And inside the while loop is another block of code. And nested inside here, it's perfectly fine to do a selection structure. So I can say if, and now I'm checking if value is greater than 0, and I can have nested in yet another block of code. And only in that case do I set pos count to pos count plus 1. So that's set. And then I can set sum to sum plus whatever that value was. Right? So this is a even more nested block of code. And this is a part of why we call this is more structured programming than assembly. Because when you're writing assembly or machine code, you lose track of where the blocks of code are. But when you're writing in pseudocode, these constructs like a while or an if, they delimit blocks of code. And we use indentation to visually indicate where the blocks are. And I even drop lines down. Some languages use curly braces to indicate the beginning and the end of a block of code. So this is actually complete. So we can begin to trace through what would happen as we ran this program. So we're going to read in some positive numbers. There's no displaying the prompt, so let's assume that we know. We're going to execute this code. So as I execute this line of code where I set sum to 0, sum gets the value 0, and I set pos count equal to 0 right here. Pos count is a 0, and now I'm at the while loop, and I can check my condition. Is pos count less than 10? And is 0 less than 10? That's true. So then I can read value. And value is whatever somebody happens to type. So let's imagine that I'm going to type the sequence of numbers 7, 4, minus 1, 2, and I'll just repeat that sequence of numbers, right? So 7, 4, negative 1, 2. So every third number pretty much will be a negative 1. So the value that's going to get read here is going to be a 7. So I just read in a 7. If value is greater than 0, so I'll just put that right here. I'm squeezing that in. Value greater than 0, right? Is value greater than 0? Is 7 greater than 0? That's true. So since it's true, we're going to go into this loop, and we're going to set pos count equal to pos count plus 1, and then we're going to set sum equal to sum plus value. And we come out of that if, and there's nothing else in the loop, so we come back up to the top of the loop, and we make this comparison again. Is pos count less than 10? Pos count is 1, so that's true. This is going to take a while. I might stop talking and then start playing this faster, but I'm going to continue to talk through a few iterations. We're going to read in value, so we get a 4. And if value is greater than 0, is 4 greater than 0? That's true. Then we're going to set the pos count equal to pos count plus 1. And we're going to set sum equal to sum plus value. Value is 4, so sum becomes 11. We're out of that if statement, and we're back up to the top of the loop, and we're checking if pos count, which is, pos count should have been 2 here. So we're checking whether pos count is less than 10. That is true. We're going to read value, which is a minus 1, and we're going to check if value is greater than 0. That is false. Because it's false, we don't execute that code. We go out of the if statement. There's nothing else to do, so we go back up to the while, top of the while loop. Pos count didn't change, so pos count remains 2, and that's less than 10. So it's still 2. And I don't need to say that. We read in a value, so the next value we read in is going to be a 2. If value is greater than 0, it is indeed greater than 0. We're going to set pos count equal to pos count plus 1. So pos count is no longer 2, it's now 3. We're going to set sum equal to sum plus value. Value is 2, so sum becomes 13. And we go back up to here. Pos count is 3, which is less than 10. We read in value, and value is going to be a 7. We check if value is greater than 0. That's true. We set pos count equal to pos count plus 1. That becomes a 4. Sum equals sum plus value. That's a 7, so this becomes a 20. Right? We're out of here. We're checking whether pos count is greater than 0, or is less than 10. That is true. We're going to read in value. That's going to be a 4. We're going to check if value is greater than 0. That's true. We're going to set pos count to pos count plus 1. Sum to sum plus value. Check if pos count is less than 10. That's true. We're going to read in value. Is value greater than 0? That's false. So we're going to skip all of this stuff. Is pos count less than 10? That's true. We're going to read in value. we're going to get a 2. Is value greater than 0? That's true. We're going to set pos count to pos count plus 1. That's 6. We're going to set sum to sum plus value. That's 26 because value is a 2. We should be crossing the old ones out. And then we're going to come back to the top of the while loop. Is pos count less than 10? Yes. Read in a value. 7 greater than 0. Pos count because pos count plus 1. Sum because sum plus value. That is 33. And we go back up to the loop. 7 is less than 10. We read value. We get a 4. If value is greater than 0, that's true. We set pos count equal to pos count plus 1. That's 8. We set sum equal to sum plus value. That's 37 because it's a 4. And then we come back to the loop. Is 8 less than 10? That's true. We read in value. Last thing we read was a 4, so the next thing we read is a negative 1. Is value greater than 0? That's false. So we do nothing else. We come up here. Is pos count less than 10? Yes, 8's less than 10. We read value. We get a 2. Is 2 greater than 0? That's true. We set pos count to pos count plus 1. We set sum to sum plus value, so that's 39. And we come back up. Is 9 less than 10? That's true. We read a value. The next value we read is going to be a 7. Is 7 greater than 0? That's true. We set pos count equal to pos count plus 1. We set sum equal to sum plus value. Value is a 7, so this becomes a 46. I'd like to point out that at this point in time, pos count is 10, but we still executed this line of code because we don't check this condition yet. So we don't stop the loop as soon as this condition becomes true. We don't stop the loop until we actually execute that BRLT instruction, until we execute the instruction that specifically checks it. That's important to remember. Some people might say, oh, pos count was 10. That was my condition. I'm done. That would be a mistake, right? Notice that we incremented sum after we updated pos count still. Only now, after we've set sum equal to sum plus pos count, do we come back and check the condition. 10 less than 10 is false. So now we're outside the loop and we're done with the program. And for this sequence of numbers, the sum of the positive numbers should be 46. And it should be 7 plus 4 plus 2, which is 13. And 7, 4, 2, 7, 4, 2. So we should be getting 3 times 13, which is 39, plus one more number, which would be a 7, and that's a 46. So check. That matches what we think it should be. We can kind of check it. So hopefully, I mean, I know that was probably long. I personally sometimes like to go through that rigorous, maybe pedantic process of tracing code just to make sure that, that I can think logically. I recommend that you do something similar, just to convince yourself that you understand how all of this is supposed to work, and then check against what it should be. This is an example of an event-controlled loop because I had no way of knowing how many negative numbers the user would enter.